Welcome. I love when you can say welcome and everybody actually pays attention. Thank you for that. My name is Cullen White, and I'm the Director of Computer Science here at Teach for America and a DC 09 alum. On the heels of President Obama's CS for All announcement, a proposed $4 billion for computer science education in the upcoming budget, the momentum for bringing CS to our students is at an all-time high, and I am so excited about it. So excited. Though the president's announcement is, in fact, a really, really big deal for our community, this game-changing moment would not be possible without the collective leadership of a tremendous community of CS educators and advocates all across our nation. I'm proud to welcome a number of them here today to share their resources and tools for bringing CS to our students. Without further ado, I'd love to welcome the host for today's session to the stage. Ladies and gentlemen, founder and CEO of Code.org. I was just making sure he was here. Hadi Partovi. Snuck out with me, man.
Hi there, thank you for having me. That was kind of funny. I saw the look on Cullen's face of like, oh crap, where is he? So I wanted to talk about, this session is about teaching computer science to kids, and our goal was to basically have a pretty hands-on view of what it would actually be like to do this in the classroom, rather than just talking about why do it, to talk more about how. But I wanted to spend just at least 10 minutes talking about, I guess, why we're all here, or why I do what I'm doing, and why many of the people who are going to be talking after me, why we think computer science is important. So the first thing I'd say is, a lot of people have the impression, because I represent Code.org and my hat says code, that our mission is that our kids should be learning to code. And that's actually not true. Our real view is that our schools should be teaching computer science, which is about how most things are taught, like math or English or whatnot, are taught in school. And computer science is much more broad than learning coding. People also have this assumption that computer science education is on the rise. You see the exploding, businesses and jobs and things like Google and Facebook and all these tech things coming along, and the assumption has been that the tech industry has been growing, so has the education side of this. The reality is computer science is only recently recovering after a 10-year decline. So if you look at this graph, this shows basically graduates in the field of computer science, and we're still not at the peak where we were in 2004, and the number of women in the field is now 1/2 of what it was 10 years ago. So it started picking up, and I'm very bullish about where we're going to get to, but this is not a field that is growing on its own. It's recently started recovering. I don't know if you can see this, because these slides look pretty faded. But one thing that is amazing is the number of opening jobs in this space relative to the graduates. The Bureau of Labor Statistics predicts that by 2022, there's going to be 1 million open jobs in the space. And these are literally the best paying jobs in the country. If you look at the value of a computer science education, if you compare the lifetime earnings of a high school graduate versus a college graduate versus a college computer science graduate, there's a massive difference. A computer science degree in college is 40% more valuable than an average college degree. And then consider that this is a field that has basically been declining. Now, I often ask myself, this isn't just for the kids who want to become software engineers. This is a question I have of what does a career look like for any student entering kindergarten today that'll be graduating in the year 2030. I used to tell people that, unless you want to get a career driving a truck or flipping burgers, whatever you're going to be doing is going to be impacted by technology. It now turns out there's robots that can flip burgers, and there's trucks that are driving themselves. So if you think just another 14 years away, the world is changing a lot, and I can't really think of any career that isn't going to have some impact from software changing it. Now, we all talk about this as the STEM problem. People hear this and say, oh yeah, STEM, we need to fix STEM. But there's this key point that the STEM problem is in computer science. This is a key graph to look at. Across all new jobs in STEM, 71% are computing jobs for not just computer programmers, data analysts, cybersecurity, things like that. And then if you look at the graduates in all STEM fields, only 8% of them are computer science graduates. There's a huge mismatch between what the growth is and what the industry needs and what our schools are graduating. And then, this is looking at what happens at the university level, but this problem begins in the K through 12 level. And this is a key comparison as well. 9 out of 10 parents want their child to study computer science, and they want their school to teach it. If you look at what the schools are doing, only 1 out of 4 schools teach any computer science. This is a huge mismatch. 2.5 years ago, this 9 out of 10 thing didn't exist. People weren't aware of it as like a new need. But now if you ask both the parents and the students, there's a high expectation that schools should be teaching this. The other thing you hear about a lot is the gender gap in technology, and that also starts in K through 12. You hear about how Google has only 18% women, or all these tech companies are overly male. It turns out that computer science has this gender gap that stretches as far back as high school. And the other thing is relevant is if you consider that only 1 out of 4 high schools even offers the course, that's actually not the real picture. This is what the high school picture looks like, because 1/4 of those kids aren't getting seen a computer science class, which means they aren't going to major it in college and they aren't going to enter that workforce. So there's a huge opportunity we can unlock by getting both a balanced representation in these classes and getting all schools to expose the kids to this opportunity. Now, a lot of this sort of tone and message around computer science is about the economic opportunity. The core reason Code.org emphasizes computer science is for the foundational learning. When I went to high school, every student would learn about the digestive system and what an esophagus was. Every student would learn the basics of how electricity works to light up a light bulb or resistors or capacitors. Every student would learn that a squared plus b squared equals c squared. We weren't sure why, but it's something you needed to know. In this day and age, it's equally important for every student to understand the basics of what an algorithm is or how the internet works. You definitely use these things more often than you use a squared plus b squared equals c squared in terms of your daily life, and they're all important. But these two things are not being taught in the majority of America's schools. The other thing that's amazing, and this has also changed just in the last 3 years, among K through 12 teachers, 56% not only believe that this field should be taught, they feel it should be required for all students to learn. And in fact, if you look in lower income districts, 65% of teachers in low income districts think it should be required for every single student. So the demand for this field is an all-time high. And then what Cullen just referred to is just this past weekend, President Obama didn't just announce funding for computer science, he announced that in this new economy, computer science is no longer an optional skill. It's a basic skill alongside reading, writing, and arithmetic. The funding actually that Cullen announced is, the president proposed a $4 billion budget for the field. It's up for the Congress to choose to legislate a budget that actually supports the president's proposal. The chances of that actually happening are about as high as any chance of any congressional bill supporting the president's budget. But what's much more important is just setting down that this is now no longer an optional skill. It's something every child should learn. So the real question before us is, can the public education system evolve? People look at America's education system, they usually don't think of it as like part of America's leading the rest of the world. They look at, everybody else's test scores are higher and we're worse at this or that, or graduation rates. But in this particular field, I very much believe our education system can evolve. Education has always evolved. It used to be that we'd teach math with something that looked like this, and in the span of about 40 years, every single school in America gives every single child a device that's almost as expensive as a Chromebook, and it's built into math class now for every single kid. And so really the question is, how long is it going to take us to evolve to adopt computer science, both as a field that every child gets exposed to, and as a tool that's integrated not only as its own standalone course, but as part of learning math or part of learning science, part of other courses as well. Now, usually this is the point that a nonprofit would say, this is a huge problem and we can't solve it and we need your help. I would actually say this is a huge problem, but we are solving it. And in fact, America is leading the entire world at solving this problem at an unprecedented pace. In what has now been just 2.5 years, so just think 2.5 years, compare that to a college education or a 4-year high school period. Over 400 organizations have joined forces to solve this problem, Over 100 school districts in this country have all embraced computer science, including all of the largest ones: New York, Los Angeles, Chicago, Miami, Las Vegas, Houston, San Francisco, most recently Oakland. All of these districts have said this is going to be a course that needs to go into every single high school. Many of them have said it needs to go into every single elementary school. There's multiple districts that have already, in just 2.5 years, rolled it out and made it available in every single school. 20,000 new teachers have been trained to teach computer science. 85% of them are women, which is important because this is a field that has predominantly been majority taught by men, which is not how most teachers are sort of in terms of the gender balance. But in this field, it's been an all-male teaching group. But the new teachers of computer science represent basically the basic gender balance among all teachers. Over 10% of all the students in grades K through 8 have begun coding just in the last 2.5 years, which is a huge change. 43% of them are girls as well. And then at the policy level, 18 states have changed graduation policy in just 2.5 years, and 7 entire countries outside the US have looked at what's happening in the US and have announced nationwide rollouts of computer science curriculum. So all of this is an amazing level of pace of change for our country, and it's something we should be proud of as a country because we're literally leading the world, and other countries are doing top-down curriculum changes because of this. Now, we're not a country that can do a top-down curriculum change. The president can say, that this is important, but education in the United States is very much driven locally. It's driven not just at the state level, but at the school level and at the teacher level. And what's most important is for teachers to decide that this is important. And I think very many teachers do already realize that this is important, but it's really up to you to introduce computer science in your own schools, to recognize that this is something that is high up as the president. He's saying it's important, and the actual power to make that change happen is kind of decentralized, and the people who have the most power to create the change actually are our teaching workforce, which is you guys. This is a picture. I just want to give a little bit of message of how students feel about this, because we're all in this at the end of the day for students. And I just wanted to show some testimonials from people who are engaging in computer science. This is a student from Nampa, Idaho in middle school saying, "I loved it purely and wholly. It was fun to do. I just want to do that over and over again because I really enjoyed what I could do with it. I enjoyed its interactivity and how it felt to control what happened. It felt really satisfying to me. I wish we could do it every day." When students react to something like that, teachers want to do it more. That's not how your students react to most things you teach them. If they said that about everything else you put in the classroom, our jobs would be easy. This is a field that kids really identify with because they have iPads or whatever at home. They're playing on their smartphones, and they relate to this. As a teacher also, this is something that is great for teachers. Here's a quote for a teacher saying, "The highlight for me was seeing the pride and excitement on the faces of my first graders when they successfully created animations and drawings by actually writing lines of code. Never in my wildest dreams did I think I'd be teaching coding to first graders." This is something that at the teacher level also resonates, and it's really just about taking that plunge. Nobody got into teaching thinking they're going to be teaching computer science, because this is something that none of us learned when we were in schools, but it's on us to basically introduce it into our courses. Now, computer science has already become the fastest spreading course in public education. Schools that do offer it are seeing record enrollment by students. This is a graph of the AP computer science course in high school. So you see this extremely sharp curve where it's doubled in student enrollment in just about 2 or 3 years. But it's, when I say it's doubled by student enrollment, that's a big deal, and no other AP course has grown so quickly. But if you look at the tiny numbers on the left, it's gone from about 20,000 students to 50,000 students. Our high schools have 16 million students, so 50,000 of them are taking the AP computer science exam. So it needs to double a lot more times to get there. And the reason it's hard to grow this is only 5% of America's high schools even teach this course. So in that 5% of schools, the kids really want it. In the 95% of schools that aren't teaching this course, those kids are basically blocked from the opportunity to learn this course. And this brings me back down to what I said, the graph I showed initially, which is that, I don't know why this slide isn't showing up. Hello? Oh, sorry. So this picture that I showed initially, that 9 in 10 parents want their children to study computer science, and only 1 in 4 schools teach it. So that collectively is the reason why we should all, I hope in this room, and I hope you already came here thinking that you want to do something about computer science, but the reasons to be teaching it isn't just because you've heard that it's important. and it's not just because of the jobs, it's because it's foundational learning no matter what career your kids decide to go into. And pretty much it's at the point that everybody wants it. It's about turning into action. So I wanted to first start by introducing two teachers who are going to talk about their own experiences bringing computer science to their classrooms. Jayshree Shankar from South Carolina, and then after her, Johnny Levin. So Jayshree, why don't you come up first? Oh, I'm sorry, Johnny's going to come up first. They put them on the wrong one.
Good afternoon. It's mediocre. Good afternoon. So there's a slide with my pictures, right? Oh, it's so good. So these are some of my students, and I started off as a math teacher in Los Angeles, and suddenly, after my 2 years, there was an opening to go to a digital arts classroom. So I took it because I wanted to work with computers and with students. It ended up being mostly a Photoshop class, but at the end of that first year, the curriculum coordinator for technology came up to me and they're like, we need someone to pilot Scratch, which is this block-based programming. I had never heard of it, I never played with it, but I kind of opened it up and I was in my English teacher's classroom, and it was like, if you click this button, the cat will meow. So I did it, and I was like, this is the coolest thing ever. So then I went in front of my students, I was like, guys, we're gonna do something new that no one's ever done at this school, and we're gonna start working with this program called Scratch, which led to about 10 weeks of me having no idea what I was doing, the kids having no idea what they were doing, and we just kind of figured it out along the way. That kind of evolved throughout the next few years. So my graphic arts class started having more and more coding and programming components to it. And eventually I switched to a middle school because the principal came up and they're like, we need a technology teacher. You can do whatever you want as long as there's something with coding. Because coding was a very big buzzword at the time. So I had a lot of flexibility, which was amazing. And I was working with all grade levels so I could do different sequences of curriculum. So I started kind of doing what every teacher does when they have a big blank slate, and that's just asking for resources and asking for help. So I just started emailing. There were about hundreds of grants that went on to Donors Choose, just asking for toys or different programs and Googling resources like code.org or some of the other people you guys are going to be seeing today. But I have some pictures of my students doing some of my favorite projects that we did. On the right side is, after doing Scratch, students got to design their own video game controllers using Makey-Makeys. So they're playing a game that they programmed, I think, or a Super Mario that they found online, depending on what they felt like doing. And then they use Play-Doh to design the keys, and they use very simple circuitry to design their game boards. And that, the first time I did that Makey-Makey project, so now when I go in, I'm like, guys, we're doing Makey-Makeys today, and it's very normal for me. But the first time I emailed my entire staff, I was like, I have no idea what I'm doing. Science teachers, I need a lab template. English teachers, I need to know how to structure this. PE teachers, I need help with management. And so I just had to go and be vulnerable, and I had a lot of teachers coming in, and then eventually that kind of blossomed into other projects. And then my favorite project, because it kind of put everything together, on the left side you see my students. This is my homegrown robotics kit. I went to my friend who does some programming, and I was like, I want to do robotics. And he's like, you should do Arduinos. So I asked for Arduinos, and Google responded on Donors Choose and said, here are some Arduinos, here are some, we also got a 3D printer, and we kind of built our own robots. And literally every day I walked in and I was like, guys, today we're gonna attach wheels to the cars. I have no idea how to do that, but we're gonna do it, and then we're gonna enter this code, and it's gonna make them spin. So it was really exciting for me to always be doing new things, and I kind of just had to take the leap. And the kids really appreciated the hands-on approach to the classroom, and I think it was really scary for me as a teacher, but it's really fun because my job's no longer I'm the master of all information. It's, I'm gonna help you problem solve this, and we're gonna troubleshoot it and just try a lot of different things. So that's a little insight into how I approach teaching computer science, and then you'll get to hear more from our next speaker.
Hi, everyone. My name is Jayshree. I teach in King Street, South Carolina. I am an 8th grade science teacher, in a small town, and so my context is very rural, where the conversation around computer science doesn't always exist. Hadi did a really nice job, I think, of explaining a lot of those larger school districts, and I think my approach to computer science has been more of an informal, starting the conversation and planting the seeds for my kids. And so what you'll see up on the screen is a collection of pictures of my students from the last couple of years. The reason I started doing anything with computer science, I never took a comp sci course in college and high school. I was a biology major, I'm a science teacher, and so I'd never had a background in comp sci, but the reason I started was because a group of about 14 or 15 of us in South Carolina worked with Google to bring the Google CS First curriculum to our schools. It's a completely very easy, very low-lift curriculum to bring to an after-school club, and it sounded cool. It sounded like something my kids would want to do, so I was like, great, let's do it. And seeing that, I think, made me a believer. So watching my kids interact with that, watching them ask questions to me, to each other, watching them problem solve with each other, I think is what kind of started that spark for me. And so about 3 weeks after my first Google CS First Club ended, another teacher came to me and said, listen, you're the science teacher, so you must know robotics. You're going to be coaching the club. And so I said, okay. However, if we remember, Jayshree does not know computer science. Jayshree has never coded anything, built a robot, nothing. So I spent like 3 weeks calling the PhD, robotics PhD department at the University of South Carolina and was like, I need some help. You see, I have children who want to make a robot and I don't know how to do it. And so I ended up coaching the robotics team. We went to the first LEGO League conference in Florence. We worked with a PhD student in robotics who came and did a lot of the technical work with the kids. And I was doing a lot of the support as much as I could, which was very minimal, except for really asking questions. And I think that was, like Johnny shared, I went from being the person who was holding all of the content because I literally knew nothing to the person who was just helping them work through problems, and they were coming to those discoveries themselves. So after going through that, after doing a lot of work with more Google CS First, one of the pictures you see up here, if you look at the bottom right corner of the slide, this year we actually kind of expanded that work and said that, you know, one club at a time is awesome, but we have so many children in South Carolina who are asking for this, who are asking their teachers about more Google CS First, who are asking for more opportunities. So we worked with NC WIT and some local nonprofits to actually bring a coding camp for over 100 girls across the state to South Carolina. Worked with the nonprofit InTech, which you'll see on the shirts. And so I think the biggest thing for me has been that I do not know computer science myself. Going through this experience with my students has made me want to learn how to teach it and eventually transition to teaching computer science. But to me, it's more about finding the pathways that kids are asking for. So if kids are interested, the pathways exist, and there's so many people here who will tell you about all of these different resources, so you yourself don't actually have to know. You just have to know where to go to help kids figure it out. So I hope you all enjoy what you hear about today, and I hope you'll consider bringing it to your classrooms.
So we all heard from both Jayshree and Johnny about how, you know, they, without any prior sort of college degrees or even single course in computer science, did this. This is a pretty unique session in that we have leaders of multiple of the different leading computer science programs at elementary school, middle school, high school, all here to give you each about a 10-minute preview of the stuff each of our courses do. So I'm going to do that first for Code.org's program. We're one of the larger providers of curriculum and PD in computer science, but many of the others are here as well, and we're going to go through a bunch of them together. So the people we're going to hear from, besides myself, Emmanuel Scanzer is here to represent Bootstrap, and Bootstrap is a program for integrating computer science into a math class. So if you're a math teacher at the basically 8th or 9th grade is their sweet spot, the Bootstrap program is fantastic for integrating into math. And in fact, starting today, we're announcing that Code.org is picking Bootstrap as its preferred PD provider for offering this integration of computer science and math. Jeremy Keeshan is from CodeHS, has a fantastic program for integrating high school computer science using an online course at an intro level or as an AP level. Tiffany Barnes is here to represent the Beauty and Joy of Computing, which is a Berkeley-driven course around the new AP course, the AP Computer Science Principles course. And then lastly, Maria Kuvaris and her team from ScriptEd. She's a TFA graduate, and her program throughout New York City has been integrating a whole bunch of both computer science, coding, HTML, and scripting after-school activities for schools and connecting the kids to internships to apply them. So each of these folks will describe their own programs. I'm going to start talking about our programs both at the elementary school and at the high school level. So, I first want to ask how many people here have either done or heard of the Hour of Code? Okay, that's a pretty good raise of hands, wow. So how many people have done the Hour of Code? All right, so at least half of you have not. So the Hour of Code, as I guess you're all familiar, has been this campaign to get schools everywhere to try at least 1 hour of coding, not just for the kids to realize that they can do it, but for the teachers as well. And it's the easiest way to get involved in something. People ask me regularly, what can you learn in an hour? Because 1 hour is not enough to become a mathematician. You don't do an hour of math. You don't do an hour of biology. The goal of the Hour of Code isn't to learn coding. It's to learn that this can be more fun. It starts by showing your kids that they have things like Minecraft or Star Wars or Frozen integrated into coding activities. It's also to learn that it's easier than you think, at elementary school especially, but even in middle school or in high school. Even at the college level, if you want to start learning to code, it starts by dragging and dropping. So you drag little blocks to tell the computer what to do. You can type in typing languages if you want, but when you're a beginner, it starts much, much easier. You don't need to learn about the semicolons or the angle brackets if you don't want to. And then lastly, you'll learn that coding and computer programming teaches other things too. Your kids can make drawings that look as beautiful as that, but while they're doing it, and that's something they'll go home and show their mom, but they also need to learn the angles to make that happen. And it's so much more fun to learn the angles in the context of making that than in the context of answering a multiple choice question. So I'm going to show one of the code.org tutorials in this space. Let me see how I can get into this. All right, can you guys see that up there? We have this funky setup where I can't see what's on my computer, so I need to kind of blindly, I have like a monitor down there to look at, so all the other presenters get used to it. You're going to be looking down there while you're working. So if you go to our Code Studio platform, there's a whole bunch of tutorials here. There's multiple 20-hour courses for all ages, but they're most useful to teach in elementary school. But I'll show just one of our 1-hour courses. One of the most popular ones, and the one that I'm personally very proud of, is our Star Wars course. This is a 1-hour course, and you have a block-based version of it and a JavaScript version of it. And I'll give you a short 5-minute view of what this looks like. I'm going to dismiss the video because it's a bunch to do. So the goal of this puzzle is, this is a series of puzzles, and the first one you need to get BB-8, the little droid, to get to the scrap metal. There would have been a video introducing you to this and telling you what you need to do. You can make the music a little bit more. Like 10% of what it was, it's good music. But anyway, you can see that basically it says right here, when run, move right, and you need a second move right command to get BB-8 to get from here to there. So I'm going to say when run, move right, and then you hit run. And yay, BB-8 got to his scrap metal, and it says you just wrote your first 2 lines of code, and it shows these are the 2 lines of code you wrote. Even at universities like Berkeley and Harvard, coding starts with dragging and dropping blocks, and you get a little bit of a sense of accomplishment. But those weren't really complicated lines of code to write. This is slightly more difficult. You say move right, move down, move down. This is extremely simple. It's something any 8-year-old or even 7-year-old can do. But starting with these really simple steps gives kids, as well as the teacher, the confidence, and it's also a lot more fun than most of the other things people are doing in their classes. So no offense to the rest of things you guys do in your classes. Kids love this stuff. But then we quickly make it a lot more interactive. So here's an example of a level where Princess Leia is not telling you need to code R2-D2 to get to all these pilots. And these things up here say the sort of different actions. When the up arrow is clicked, you can say you want R2-D2 to go up. When the down arrow is clicked, R2-D2 is going to go down. When the left arrow is clicked, R2-D2 goes left. And if you want to mess these up, you can say when right, go left, and when left, go right. And kids love messing around. So now you hit the run button. I'm going to get confused doing this. But this very simple level of interactivity is the beginnings of making something that does something. That's not your proudest moment to make that, but it's still kind of cool. At the end of this 1 hour thing, you end, it gets more and more complicated. I'll just show you the last level, which most kids can get here in 20 minutes. It's to build a much more complicated program. So now, you set the scene when you start. So you can say, when I start, I'm going to start on a starship, and I'm going to make the map have blobs in it. I don't know what that means. The droid is going to be R2-D2, but he's going to be super fast. And then I'm going to do all those things I did before, where when he moves up, the up arrow will move him up. The down arrow, oops, I didn't do that right. The up arrow will move him up. The down arrow will move him down. The left arrow will move him left. And the right arrow will move him right. That stuff was easy. But then the other things we want to do is to say, let's also add some people into here. So we're going to add a stormtrooper onto his field. And actually, let's put a few more stormtroopers. I'm going to add another stormtrooper. And then we can say, what happens when he gets into and he hits a stormtrooper? So when he gets any character, or actually doesn't matter whether he gets any character, when he gets a stormtrooper, one thing we can do is play some sounds. So we're going to have him play some random R2-D2 sounds. These sounds are super cute. And then anytime he gets a stormtrooper, we'll add 2 stormtroopers to the field. And this is something that, if you know your math, you can quickly get lots of stormtroopers. And then we can also add some score. Somewhere here there's a score. So I'm going to add points. And kids love having lots of points. So this you can choose 10, 20, or 30, or 1,000 points for every stormtrooper. So now you have the beginnings of a very simple game. I'll hit the run button. And R2-D2 is super fast. And he can get a bunch of stormtroopers. So if you're enjoying this, young kids love that. And what's most awesome about this is when they're finished with this, they can share this game. They can send it to their phone. You just type a phone number and you get it on your phone, or you can get the URL for it. And I don't know how to do this. The URL for that basically gives you a sharing. Well, that's not going to work. But you basically get a URL that you can post to Facebook or send to your phone. That game I just was playing, you could literally play on your phone, swiping up and down and getting stormtroopers, which is super fun. All of our elementary school courses have this level of sort of gameplay feel to them, while creating real things like cool drawings or games that you can share. At the high school level, we do a bunch more, but I want to give you a quick demo of how our programs at high school work. This here is a simple programming environment with more mature programming, so it's designed for a high school kid, and it's part of our computer science principles class, or APCS principles class. So it's similar in that you see a bunch of blocks on the left and a little play area on the, blocks in the middle and a play area on the left, but instead of R2-D2 or stormtroopers, you just get a blank slate. You can make whatever you want. I'm going to start by making the beginnings of a very basic app. So I'm going to move into design mode, and I'm going to say, let's make the back of this screen. We're going to choose a color here. There's a beautiful color. And then I'm going to put a button on the screen and a text input on the screen. And I can say, this text input is enter a number. And this button, when you click it, you'll draw. And I'll put some instructions on the screen saying, draw a polygon. And I can change the font size because you probably can't see that. Right, so draw a polygon and enter a number. So that's our basic screen here. And now I can put up some code that connects to it. So what do we need to do to draw a polygon when somebody puts a number here and clicks the draw button? So first you need to put an event handler. So on the event that the button gets clicked, some code needs to run. And that code needs to look and see what's the number that they put over here. To do that, we need a variable. So I'm going to say the variable x is going to be set to the text value. So we're going to get the text from the text input. So whenever button 1 is clicked, the variable x is going to store the data that's in that text input. That's enough for us to basically just get a number and say what that number is. And you can basically write simple code just to test that. I'm going to add a little bit more code. I'm going to add what's called a loop, a for loop. So I'm going to count from 0 to x. So I'm going to draw a polygon with x sides. Now you can see all this is using drag and drop, but I can actually click and switch what I'm doing from drag and drop to real code. And in fact, I can switch it right back to drag and drop and back to real code. This is really interesting because any of you who've seen typing code, it looks hard and scary, and if you mess it up, it's hard to fix it. So if you're scared of that, you can do it in blocks. If you have a classroom with kids who already know how to do the drag and drop and they think that's boring and for little kids, you can have half the class do it one way and half the class do it the other way. And if they get too far along and stuck, they can switch back to the blocks. So just to finish this really simple app, we're going to go x times and draw a line. So I'm going to have a little turtle drawing thing move forward, maybe 50 pixels, and then turn right by an angle. And then you need to learn what's the angle to draw a polygon of x sides. It's 360 degrees divided by x. So that should work if I don't mess it up. So I hit run, and I can enter number 5, and if I'm lucky, I'll get a yay. So this isn't the world's coolest app, but we literally built it in 4 minutes. And what's also super cool about this is this too you can share and get a link, and that link, or you can send it to your phone. And when you see that thing that you just created on your phone, it's just a very cool experience. It basically looks like this on your phone, and then you can enter a number 6 and draw a line, and make cooler shapes. That's the very beginning of learning that you can create what you want, and it's super cool. So getting back to where we were on the slides, I just want to give 2 pointers on where you can learn more about this stuff. If you're a teacher in elementary school, if you're near any of the points on that map, which is basically anywhere in the country other than Montana, there's workshops that teach how to integrate this stuff into your elementary school. They're one-day workshops. They're free. They're literally rated the best PD ever by over 20,000 teachers who've gone to them. You don't need to go to a workshop to integrate our stuff. If what you saw made it look easy enough, you could just go ahead and do it. But you can find that map at code.org. Please check it out if you're in elementary school. If you're in middle or high school, it's a little bit harder because you can't just add a CS class to your high school curriculum. We love after-school clubs, but we mostly want high school teachers to make full CS classes part of the curriculum. But you can start by doing the hour of code just to get your kids or your school used to it. But really, you need to ask your administration to make computer science part of the school schedule. We host professional development in many partner regions. So if you look at the number of cities or states, if you live in any of those cities or any of those states, chances are high that your school district or your entire state is in a partnership with code.org. And then at the high school level, we offer PD programs for any existing teacher, any field you're in, to learn enough to teach a full year course. Our goal is to get full year intro courses and full year AP courses into every high school that wants one. There's a TFA alum, Jake, who's going to stand up right now. Yay, Jake. Jake manages our team that basically partners with schools and districts to get computer science in there. So if you're in a middle school or high school in any of those regions, please talk to Jake after this talk. I think that's it for me.
This is the first time I've ever done computer science.
Is that my call for somebody else? Oh, I'm supposed to let it go?
This is the first time I've ever done computer science. It's easier than I thought it would be. We're using algebra and addition and subtraction and things that we already know to ultimately create a video game.
I made a game called Space Survival, where basically you were just dodging asteroids and trying to catch fuel tanks. There's a player, a danger, and a target.
I've always wanted to create video games.
Like this guy running for an ice cream cone.
Awesome.
It's called Shark Attack. It's basically you're Nemo and you're trying to avoid sharks, meanwhile collecting turtles.
The first thing we learned that kind of impressed me was like a different way to do math.
Basically, each circle is a set of parentheses.
This way of solving math problems in a very simple, sort of tidy package.
So there's 4, 0, and then here's the line length, which is the function.
That's the computer giving you a hint. It's letting you know when your parentheses match, and that's really valuable when we start getting into more complicated things.
It's different and it's new because I've never done this type of thinking before.
Coding is evolving to the point where it can pretty much do anything.
Programming isn't as hard as it seems. It's actually really easy when you follow this.
It's just really a concept that you can apply to everything and everything. I just love working with this.
It's actually pretty fun. I think it'll help me in the future.
I just think it helps me think better as a person.
If I continue this, it'll become really easy and I'll just be able to do it. Maybe one day with my eyes closed. I'll have to work on my typing.
It kind of like pushes me when there's like some kind of invalid syntax. And I'm like, okay, what's wrong? The computer doesn't like this, it doesn't process it, so now I have to figure out what's wrong.
Before I came here, I wasn't that excited, but now I think that programming is a lot more fun than I thought.
It's really fun, really easy. I definitely believe that kids should learn computer science.
All right, good afternoon, everybody. My name is Emmanuel Schenzer. I'm the founder and one of the co-directors of Bootstrap. So Bootstrap is a carefully aligned sequence of research-based computing curricula that spans from middle school to high school and beyond. And you'll have to pardon my voice. I'm a little bit sick right now, so I'm going to give you the sultry tones of computer science. So look, a lot of people are talking about putting computer science in every school, and that's fantastic. But CS electives and after-school programs are only the first step, because they suffer from what I call the opt-in problem. No matter how diverse your school's population might be, the kids who self-select into these electives often don't represent that same diversity. So look, I'm personally not that interested in scale unless it comes along with equity. So at Bootstrap, we want to put computing in front of every student. And so I want to start off by framing this with a question. Whoa, what slide is this? All right. So what if you could make programming available to every student, regardless of their gender, their race, or their income, without having to find room in the budget for a new teacher or room in the schedule for a new course? So this sounds really great, right? Like, why not do that? That's wonderful. But of course, there's a finite number of hours in the school day, and kids still need to be passing their core classes. So how do we address this? Well, at Bootstrap, we do it by putting algebra first. We leverage the existing infrastructure of tens of thousands of math teachers across the country, and we make sure that the kind of computing we're teaching is directly applicable to the same pencil and paper standard algebra tasks that students need to master. So, why algebra? Like, who cares about algebra, right? This is all about computing. I'll give you 4 reasons. First, Piaget himself calls algebraic functions the dividing line between concrete and formal operational thinking. So if you care about abstraction, you care about algebra. Number 2, algebra is the gateway class to all STEM. So yeah, we understand that if a kid fails Algebra 1, they're sort of screwed for calculus, right? Duh. But what we often forget is that if you don't know algebraic functions, you ain't modeling projectile motion in physics. You're not balancing chemical equations, you're not modeling population growth or rates of change in biology, and you sure as heck aren't being a computer scientist. So we care about any of those things, we care about success in algebra. But what if it's all about the Benjamins for you? That's okay too. A 2004 study found that of all the grades a student gets in high school, the grade they get in their first year of algebra is the most strongly correlated with the amount of money they're going to make for the rest of their life. And finally, love it or hate it, we live in an era of high-stakes testing and standardized tests. And is it the ELA or is it the math test that people often freak out about when they say we're falling behind other countries? Which is it? It's the math, right? And what part of the math test? Is it the like arithmetic or is it the word problems in the algebra? It's the algebra, that's right. So given how incredibly important this stuff is, how do we feel about algebra as a country? We're terrified, right? We're absolutely terrified. So why? Why is algebra so hard? To understand that, you got to take a step back and picture yourself as a 3-year-old. What do we tell our young students what math is? Math looks like this. So pretend you're all 3. We'll do some audience participation. I'm going to be your teacher, and when I do this, I want you to shout out the answer to the thing in red, okay? All right, kids, 4 plus 2 equals? 6. Oh, congratulations, you're all right, good for you. And what we learned at the time was that math is a process, right? Maybe you held up 2 fingers, and then 4 fingers, and then you counted all your fingers, and then you got the answer. And as we got older, that process got more complex. We added multiplication, division, subtraction, exponentiation, order of operations, fractions, you name it. But every step of the way, every time we saw a piece of math, our job was to compute the process and get the answer. As kids get older, math looks like this. All right, class, solve the thing in red. 1, 2, 3, what is it? 4, fantastic, gold star. But 10 years later, we're starting to take our first steps into Algebra 1, and suddenly math looks like this. All right, class, solve the thing in red. Crickets. What's going on here? Well, if you're a kid who's sitting there thinking that math is a process and your job is to get the answer, this makes no sense. You think, I don't know what the answer is, because this isn't a question anymore. In Algebra 1, math itself changes. It's no longer about a process of computing an answer, but instead we introduce these abstract objects called functions. And an algebra teacher spends time asking questions like, what's the image of this function? Is it one-to-one or onto? Is it linear or exponential? And if you're a student who's sitting there thinking that you're supposed to calculate a process, which you've been told for 10 years you should, this isn't just hard, it's nonsense, because math itself has changed. But it gets worse. Because algebra teachers have to talk about functions as having multiple representations. We talk about functions as being symbols in a formula, or lines on a graph, or values in a table, or a mapping between domain and range, right? Is it one-to-one or onto? And we have to teach kids not only to think in these ways, but to realize they're connected. So here's what the last 45 years of research tell us. To truly move the needle in algebra, you got to make representations of functions concrete and connected. And in honor of tomorrow's Super Bowl, I would say these are our goalposts. But wait, programming has functions, right? Programming is like math, right? So what if we just taught all the kids to program and then prayed to the gods of computational thinking? Well, then computer science would just transfer into algebra and kids would all start doing better at math, right? Right? Fantastic. And 45 years ago, a brilliant mathematician published a paper on a language called Logo, in which he said learning to program will teach algebra. And now we've got tens of millions of kids learning to code in all these different languages. And as we all know, all of those children are now performing beautifully and getting A's into math, right? Didn't happen. Why not? I'm going to share a dirty secret with you. Much of the programming that students see not only has nothing to do with math, but is math hostile. And I'll give you an example. Hey kids, welcome to Programming 101. Here's a simple program. The first line sets a variable x to be the value 10, and the second line of code adds 2 to that variable and stores it back into x. So I click run, and what's the value of x when this thing is over? 12, congratulations. Of course it's 12. Of course it's 12, right? Math teachers, why are we furious right now? Yeah, because you can't set x equal to x plus 2. Subtract x on both sides, you've just proven that 0 equals 2. So every math teacher in this room knows that x is not a variable. And this is because most of the programming languages we teach in K-12 have things they call functions and variables that are neither functions nor variables. And so if you want to help a kid in algebra, none of these are going to work. Now the good news is there are a lot of languages that do behave like algebra, and they're perfect for teaching math. But weirdly enough, almost no one uses them in K-12. We do. Bootstrap is both an algebraic programming language and a curriculum and series of pedagogy that are written by math teachers for math teachers. We teach structured problem solving because oftentimes it's easy for us to trick ourselves into thinking that we're teaching problem solving simply because we give kids problems to solve, right? So in Bootstrap, students, when they're confronted with a problem, they focus on multiple representations of functions. They systematically build from concrete examples to abstractions. We embrace national and state standards for best practices in algebra. So if you're a math teacher with no computing background, Bootstrap is going to feel incredibly natural for you. It's also a complete curriculum. That means we're giving you not just lesson plans and standard alignments, but also warm-up activities, slides, exit slips, homework, and an integrated student workbook. Because if you're handed just a piece of software and some lesson plans, they're assuming there that you have enough free time to build all these things yourselves, and we know teachers are busy. So at 10,000 feet, what does the curriculum look like? The very first thing students do is brainstorm a video game of their own design. They feel like they own it, they feel like it's creative, it's got like a fish moving across the ocean and like trying to get Jolly Ranchers and trying to avoid sharks. And then we cash in on that engagement by teaching them something called the circles of evaluation, which are not fully showing up on this slide, but that's okay. The circles of evaluation are essentially a visual spatial metaphor for order of operations that transitions smoothly into function composition. We then have students learn how to define functions of their own, and the first function they define is a rocket blasting off. And they do this in the context of a word problem, and from this moment on, the entire curriculum is nothing but word problems. You'll notice they're solving it using multiple representations here. Now, at this point, students are saying, the rocket flying is great, but what about my game? What about my Jolly Rancher moving through the ocean? Well, guess what? The same word problem can be applied directly to their games. So students type it in, they see the Jolly Rancher fly across the screen and never come back. And so they're happy that it flew, but they're pissed it didn't come back. And they say, when it goes off the edge, it should come back. And the math teacher says, well, when does it go off the edge? And they say, well, whenever x is less than 0. That's inequalities in the plane. So we have students do a compound inequality to trap a butterfly in his mom's yard. And then they apply that math to their game to do boundary detection. And now they want their leprechaun to move up and move down, depending on which key they pressed. And the kid is saying, well, wait a second. How can a function act 2 different ways? That doesn't make sense. How do we do that? Math teacher says, oh, well, there's a little thing called piecewise functions. Right? Depending on the subdomain, a function has different behaviors. And we do this at the middle school and early high school level, because when students are engaged and built and the math has to do with a problem they want to solve, you can push them harder than you ever thought possible. And finally, students are saying, well, great, my game's moving, everything's great, but when my fish and the shark collide, something should happen. And we say, well, okay, how do you know when they've collided? And they say, well, whenever they're close enough to touch. Oh, how do you find out how close 2 points are in the plane? Well, we do a geometric proof with the Pythagorean theorem, which it turns out from Hadi's thing is actually usable. And we're doing the same math. So instead of a word problem involving a ladder leaning against a brick wall, it's the same math, but it's a word problem about a leprechaun trying to get an alien or something. And kids do a video game release party. It's fantastic. Kids are showing off what they built in math class. It's like a science fair for the math department. So what's our impact? We're currently operating at scale. We're reaching more than 10,000 students every year in 17 states and 5 countries. And we're particularly happy with which students these are, because remember, every kid takes algebra. This isn't just the students who self-select. We were thrilled last year to become the first curriculum operating at scale to show measurable, statistically significant impact on standard algebra scores. We've been adopted. We work with school districts across the country. And we're the official computer science and math curriculum for the New York City Department of Ed's CS for All initiative. We've also been the foundation for course offerings from great partners like Code.org, Code for Fun, and many more. We believe that Bootstrap is the best curriculum for computing if your primary concern is algebra scores. And what's beautiful is that Bootstrap 2 and beyond build on everything students have learned from the first course. So teachers and students who found success in one realm can build on that instead of throwing everything away and starting from scratch. So that's where we're at. It's a pleasure to be here with you all, and I'll give it up to the next speaker.
Alrighty. Hi, everyone. My name is Jeremy Keeshan. I'm very excited to tell you guys about CodeHS today. So what we do at CodeHS is we help high schools teach computer science. So a little bit about me. So my name is Jeremy Keeshan. I'm the CEO and co-founder of CodeHS. A little bit on my background, how we got into this. I studied computer science at Stanford, where I was a student TA, helped teach small sections, did that for a few years, got to manage student TAs, got to lecture the big 600-person classes, got to build a lot of their course tools. And what we saw there was that basically everyone was taking computer science. Everyone goes, this is fun, this is for me, I can use these skills whether or not I'm going to go into programming, and there's just so much excitement around that. And we looked around and we say, hey, that's not what the story is, in most schools and in most other places. So now I've helped teach thousands of students in person. Through CodeHS over the last 4 years, I've gotten to do a couple big road trips around the US where I visited over 100 schools for teaching computer science. So lots of experience now teaching computer science in schools. And so what CodeHS is, basically, it's a comprehensive platform for helping schools and districts teach computer science. And what we offer, really, we say it's like a class in a box. It's really all the pieces you need. And the pieces are web-based curriculum, teacher tools and resources, and professional development. So when there's a school and they say, hey, we want to bring in a new computer science program, or we have something but we want to level it up, we sort of help schools do that. So to give you an idea of the courses we have right now, actually, we're going to have the first 4-year online computer science course sequence pathway for high schools. The courses we have now, we have Intro Computer Science in JavaScript. That's a full year-long course. We have AP Computer Science course in Java. And we're building out Intro Computer Science in Python, as well as AP Computer Science Principles. So the way that we build our curriculum and the sort of style that we focus on, there's really a few key ideas. One is focusing on concepts over syntax. We start with text-based programming, and I'm going to give you a demo of that because I know you're seeing a little bit of drag and drop today. But we still say, hey, it's, you're using text to get started, but it's still about those key ideas to get started. Low barrier to entry. It's a very visual environment, and I'm excited to show you how we start. It's called Carol the Dog. It's a very fun way to get started. Very focused on problem solving, creating games, learning about the language. And we use teaching libraries and scaffolding to allow students to create more interesting projects without all that overhead. So I'll give you a short version of how we start with Carol the Dog here before I switch into our site. But this is called Carol the Dog, and the idea here is that what coding really is, coding is like giving commands to a computer. That's what coding is. And the analogy is that giving commands to a computer, it's just like giving commands to a dog. So we start with this very friendly Carol the Dog here. Carol's a dog who lives in a grid world and only knows 4 commands. The dog can move, put down a ball, take a ball, and turn left. So the first program that students will write looks very simple. So they'll say move, move, and take a ball. So those simple commands are an easy way to get started, but still introducing text-based programming. So a big thing that we do in the CodeHS system that really is a huge help to schools and teachers getting started is just the amount of teacher tools and resources that we're providing. So the big idea is that we're just handling a lot of that overhead so you can focus on the key thing, which is working with the students. So what do we have? We have a lot of tools to manage student rosters and classes, to help track student progress, auto-graders so that actually students can do a lot more cycles of writing coding, still getting immediate feedback, but then when the teacher wants to go in and help one-on-one, there's actually a lot more time for that. Tools for quizzes and assessments and reports. For new teachers that are getting started, we have a syllabus, we have lesson plans, we have problem guides. For administrators, when they're rolling out to hundreds of students or thousands of students, we have dashboards to sort of see, hey, how is this program going? And then for teachers who are starting to get more comfortable with the materials, we have tools to customize your own problems and create your own auto-grader. So it's really the whole tool set in terms of bringing computer science into your classroom. Another big piece is the professional development side. We work with a lot of experienced computer science teachers. We also work with a lot of new computer science teachers. So maybe they're teaching math or science or business or computer apps, and it's like, hey, we're going to level up and we're going to start teaching computer science. So what we have is a online 30 to 40-hour professional development course to help new teachers learn the basics of coding and also how to go and teach it in the classroom. So some of the big ideas that we focus on teaching are just what are the basics of coding, how do you use that with the CodeHS curriculum, how to teach debugging. And what debugging is sometimes you're writing a program and it doesn't work. It's not working and the question is, how do you fix that? And so debugging is that process of creating a hypothesis and testing it and seeing how we can come and fix that. And a big thing here for us is that there's this sort of mind shift which we heard a little bit earlier, which is it's no longer that every teacher who's teaching computer science has to be the content area expert. Because a lot of times, let's say you're working on a breakout game, which you might work on later in CodeHS, and you're stuck. And the student doesn't, they don't know what to do. It's not necessarily your job as the teacher to solve it for them. That's actually not your job. Your job maybe is more to help say, hey, what are these leading questions that can help the students solve it themselves? And so there's really that process of debugging, which is what we try to teach as a big idea in our professional development course. We also teach how to grade coding problems. That's something that's pretty new for a lot of teachers who haven't worked with coding before. And we talk a lot about how to teach in a blended classroom. So who uses CodeHS? CodeHS is being used in a lot of places right now. So over 15,000 teachers have signed up for CodeHS. We're reaching over 200,000 students all over the country, all over the world, and we're working with all types of schools, public, private, charter, vocational, and homeschool. We're working with major school districts, we're working with lots of small schools, and Cullen White, who is leading the event, TFA Director of Computer Science, has previous experience with CodeHS, so definitely ask him to learn more as well. Thank you. So now I'm going to switch over to a demo. Great. Okay, so this is what you see. This is what a student sees when they log on to CodeHS. Basically, they can see their course page, which has an outline of the different modules that they'll learn. So this is right now. This is our Intro to Computer Science course in JavaScript, where the first unit is about the basics of programming, programming with Carol the dog. Then we learn a little more about the language of JavaScript and basic JavaScript and graphics. Then the next unit is animation and games. And then we'll have a breakout project, learning a little more about the basics of data structures, and then a few other games at the end. So this is a year-long course targeted for high schools. So I'll show you how we get started. So this is basically the first program that students write. And the idea here, this is Carol the dog that I showed you in the slides. But what's nice about this is that this is the editor that the students work in. And basically right here, this text over here, this is the code. This is the code. This is where the dog is starting, and then this is where you're trying to end up. And so right here, you have this very friendly environment. You're still learning the syntax of the language, but it's not too overwhelming. And then you click run, and you can run the program. And this is sort of right where we get started. So really, really visual still, really friendly to get started. And then Carol builds up and up and up. And you're really, actually in Carol, actually it's fun. I get to send sometimes some of our more advanced Carol problems to maybe even a PhD student. And the idea is that what Carol is Carol is really a way to think about algorithms, a way to think about problem solving, but still in a very, very friendly way. So we have mostly high schools, a lot of middle schools doing it, but you have this fun, friendly way to get started. And then later on in the course, so I'm just going to show you sort of where we start and where we get to. Students are writing a game like this. So this is the breakout game, brick breaker game. And what's crazy is you see we just started with those 4 basic commands, and over the course of the year, so this is usually in the second semester in your first year, students have learned all these ideas that you've sort of heard about today. What are variables? What are functions? How do we think about breaking down this complicated problem of writing this big game into smaller subproblems? They're using graphics, they're using animations, they've learned JavaScript, which is a professional level language. And so students really like that they're going from just the beginning to actually making their own real projects. And then sort of at this point, the sky's the limit from here. So we have a lot on the teacher side. I'll just show you a little bit briefly. So on the teacher side, you can manage your class and manage your roster. Then there's a lot of additional tools to sort of track student progress. You can see it sort of at a very granular level of every activity that the students are working on. You can sort of view it at a higher level for the modules. You have tools to sort of manage submissions and manage help questions. Let's see. We have a lot of additional resources, so just handouts and solution guides and lesson plans and forums and a glossary and a style guide and a syllabus. So all those questions that you're wondering about when, hey, I'm trying to teach computer science, what do I need? We have all those pieces. And when you dive in a little bit more, we have this really awesome tool called custom content, which means, hey, if you like our problems, you can use them, but if you want to make your own, you can go and create them. So that's a quick overview there. Okay, so how do you bring CodeHS to your school? Well, you can start teaching computer science at your school in about 5 minutes with CodeHS. You can sign up for a teacher account at codehs.com, and you can contact us at hello@codehs.com, and we'll work with you and your administration to bring in a new class. So the way our plans work is we have a free plan that you can use to teach all year, and as well as more support, more tools on our pro plans. The reason it's really easy to get started, there's been 15,000 teachers who say, hey, I want to try this out. I want to see what it's like to teach coding in my school. You can just get started teaching right away. And I just want to share a few great quotes that we have from teachers. We have hundreds and hundreds of these, and I think these really show and demonstrate that experience that teachers are having with their schools and their classrooms and the difference that CodeHS is making for them. The program is comprehensive, easy to use for both teachers and kids, and provides the right amount of support and feedback for learning. Another teacher, my students love it. They are engaged, they can work at their own pace. It's awesome. I truly believe the site is the most interactive way to teach programming. After using Carol and learning about functions, they said, function, we love Carol, challenging, easy to use, and thought-provoking. From another teacher in Chicago, I think you built a really great website that gives a lot of help and support, but at the same time is challenging. I've used many of the other popular websites that have beginning coding material, Khan Academy, Code Academy, and Code School, and yours is by far the best. I love learning and teaching on here. And from Charles, a teacher at Mills High School, the CodeHS system handles so much administrative overhead and frees me up to provide individual help and feedback where it's needed. And CodeHS has been a fantastic addition to our school. It's wonderful to see how accessible the system makes a subject that often seems intimidating to students. And the last one, found out a former student who did CodeHS and then went on to programming in college, tested out of his intro course from a teacher. So thank you for having me. Thanks for learning about CodeHS. And if you have more questions, feel free to come talk to me afterwards or email us. Thanks.
Good afternoon. I'm Tiffany Barnes, and this is Marnie Hill, and we're here to talk to you about the beauty and joy of computing. It's a version of the Computer Science Principles course, which is going to be offered by the College Board in 2016-2017 as a credit class that will have an AP. And I'm a professor at North Carolina State University in computer science. And I'm here because I'm passionate about bringing computer science to everyone. I'm so excited to hear all the presentations that we've had because there are so many people excited about equity in computer science, and I think everyone can learn computer science. I've been working from this end, from the college end, and I've also worked on an initiative called STARS to have college students in computer science bring computer science to kids in their communities. And I've been working on this professional development project. And this is Marnie Hill.
I'm a high school teacher from JHRS High School in Greenville, North Carolina. And the curriculum that BJC has or is easy to use. You don't have to be a teacher who is math and science. And I'm a business teacher. And it was easy for me to use and easy for me to learn and to be able to present it to the students, and it was fun and creative, and that's why I really wanted to promote it and help get it out to the world.
I wanted to mention that the project I did before this is STARS, and like I said, I have college computer science students actually working to go out to schools and bring them computer science, and that was one of the first projects I did to try to bring computer science to people outside of universities. As you see, we don't have that many people even in universities doing computer science, and they certainly don't look as diverse as this room. And one thing that was really cool is that one of the students that was in STARS designed an outreach curriculum and then got hired by Google to do CS First in South Carolina. We started in 2006 with this project, so we heard from teacher earlier today who actually started working with Google with CS First. So these projects have been going on a long time, and our STARS project has had 1,300 students in colleges that have done outreach to 120,000 K-12 students. And Beauty and Joy of Computing, I found out about that when the College Board started looking for pilots at universities to teach a college-level computer science class that could be brought down to the high school so that students could take this course in a high school and get credit for it in colleges. And I picked out Beauty and Joy of Computing as a course to implement because when I saw the programs that you could write in it, it was super fun and super easy to do. And you could make beautiful things like the tree on the left and the fractal on the right with code that looks like what's in the middle, drag and drop programming. That was very easy to do. And it was designed by Dan Garcia and Brian Harvey at UC Berkeley. And it uses the programming language called Snap, which you can use in your browser. So it's at snap.berkeley.edu. You'll see that link later on the slides. So BJC is a curriculum for CS Principles. It will be a new AP next year with an exam. Students in the class learn to program with Snap with very creative, open-ended projects, and they also learn about the benefits and potential harms of technology by reading and talking about how computer science impacts and integrates with other fields and impacts the world. And computing is the literacy of the 21st century, but as we've heard before, AP computer science is offered only in 5% of the schools across the country. And a lot of times kids consider programming and computer science geeky and hard and solitary, but they love their devices and they love games and they love being social. So there's more than one aspect, it's not just games, it's just they're using their devices for connecting with other people and doing things that they care about doing. And this course connects the kids to that.
With my classroom and in my classroom, my students are learning to problem solve and they're creating. Their core classes that they're normally in are mostly about memorizing and regurgitating information. And with my classroom, they come in and they get to change what they're doing, and it gets their minds stimulated. And then they start doing these fascinating things, and we have a great time looking at their creations, and they figure out that they can do.
And we don't have the numbers that these other wonderful projects have started. We have funding from the National Science Foundation, but we've been running professional development since 2012, and we've provided professional development to 237 teachers, and we are running again this summer. And so if you're interested in coming, we are going to have more professional development this summer for at least 70, but maybe as many as 200. There is some new funding that we might potentially get where we actually pay teachers to come to our professional development who are going to offer the course in their schools. To give you an idea of what the Computer Science Principles course is about, it was built by bringing together the top computer science educators in the country and asking them, what is the core of computer science? What does every person need to know about computer science? And I was so excited when I saw this list of big ideas because I'm a computer scientist and I love computer science, but I love to see that the very first idea is that computing is a creative activity. It's about making things, and it's about problem solving, and it's about algorithms, and also it's about data and information. It's about creating new knowledge, and about the internet, and about how computing interacts with other things and change the way we do everything. The book that we use in the class is called Blown to Bits, and it's a free book online at bitsbook.com. And it's a book of stories, and the kids read and discuss the stories that have them thinking critically about technology and how it impacts us. The very first story in the book is about a lady who's in a car accident and no one knows where she is. But she has her cell phone with her, and after they figure out that she's missing, and after they get permission to look for where she is, they can actually triangulate where she is based on where the cell phone towers last saw her phone, and she was rescued because of technology. And then the kids in Marnie's class, she was just telling me, you want to say that?
My students, I talk to them about, okay, GPS is great, right? But then, do you want to always have somebody know your location? And so then they started thinking, well, no, I don't always want to have people know where I'm at. And I said, so this is a problem. So you have the good thing that if you know your location, somebody can find you and you don't die. Or you have the bad thing that if you have your location, your parents know where you're at and you get in trouble when you get home. And so how do we balance that, and how do we fix that little issue, that little problem?
And that was a nice discussion that came up when the kids asked, like, why do I have to read this? Why are we reading this book? And the idea is that they need to think about technology and what is the impact. And also, when they think about potential problems that might be raised, they can be the creators that actually create the solutions to some of the problems that we're creating with new technologies. And so that's where the idea of programming, as a creative activity comes in. And Scratch is a great language for that. And as you've seen, many of the languages that you're seeing that we're using for courses today are based on things like Scratch, but it's not super powerful. So you can do a lot of things in Scratch, but at Berkeley, they extended Scratch to a language called Snap, which you can run in your browser, and you can actually make apps with it. So as soon as you make something in Snap, you can then run it in a browser on any mobile device, which is really cool because you don't even have to use App Inventor or something else that sort of translates the things to your device. As soon as you run it in the browser, you can run it on any device. And what it allows for that's different from the original Scratch is that you can make your own functions. And we heard from Bootstrap that making functions is like central to everything, and it's core to computer science too. So the power of computer science is that when I make something once, I don't have to make it again. I can use it again and again, so I don't have to copy and paste my code over and over. I can say, I'm going to call this thing this, and then I'm just going to use that whenever I need to. So now I'm going to do a tiny demo, and it's not going to look as cool because you already saw some other demos. But I just want to show you how super fast it is to make your own thing. So here's the game that we're going to make, and it is whack-a-mole, right? So you can run this in your browser if I were to give you the URL.
It's not showing.
Oh, it's not showing. I gotta move the window, sorry.
Yeah, so you gotta look.
I gotta see where
There
it
we
goes
go.
over there. Oh, okay. Sorry about that. I was like all playing over here, having fun doing whack-a-mole. You know, that's what the students do when you teach this, by the way. They're like, I made my game. I'm gonna play my game, by the way, for an hour. So, you know, you can play that. And what you want to do, though, is actually make that super fast, if you can move your mouse to the right place. So I'm going to show you how quickly we can make this, if I can program on another screen. All right, so we start out with Alonzo. That's the name of this guy right here, over in the left. And let's make that big. And what do we want to happen? If we click on him, we want something to happen. So we find our control block, and then we say, when I'm clicked, let's make him turn around. This is a block that was made, so it didn't come with the program. It was made, but then it appears in my toolbox. And I also want him to jump, right? So when I click on him, I want him to move. So there's some operators. I want to pick a random location. Oh, I need to actually first tell him to go somewhere. So tell him to go to an XY position. And I want it to be a random one, and there's a random function here. So I can drag that into there. And then I need to tell it coordinates, so somewhere anywhere between -140 and +140. If anybody's timing me, this should take me less than a minute to do, because we're almost done. Okay, so let's just see if that worked. All right, cool. When I click on him, he goes somewhere. And everybody wants points, right? So we need to make a variable for a score. All right. And then whenever I click on him, I want to add to my score. So let's change that score variable by 10. And now when I click this, I now have a score box that shows up. And when I click on them, I get some points. Done. And you can run this on your phone immediately. So really cool, very fast to get started making beautiful things. So we teach functions. I don't need to tell you why we teach functions. They're awesome. But now you can do them in code. You can draw a square. And the thing that Snap allows you to do that other languages are a little bit harder is if I want to do something like compose making a square with how I'm going to draw the line, I can compose those two things together in Snap, which is a pretty advanced function, and you can't do it in a lot of languages. But this starts to get students seeing things that actually they learn in some other classes, like, hey, if I'm using Word and I want to draw a dashed line, I just select this thing. And the program itself is composing functions to do that. This is a really cool program that they get to see that actually we can also make cool things in their programs. This is a V program, and the program simply says, draw a left-hand side of the V and draw the right-hand side of the V. But when you get to the end of the V, draw a shape from this list. Either a square, a hex, a star, or a V. And then when you run that program, you see that it grows little trees. And every time you run it, it looks different because you're randomly selecting one of those. And it's super creative and cool. So this is an attestation from one of our teachers. And I'll just end with letting Marnie tell you what kind of students are in your class.
So in my classroom right now, I have 13 students in my class taking this one. A whole bunch of seniors dropped because it's fourth period. And they didn't want a fourth period class. So I have 13 students, and 3 of those are white males, and the rest are underrepresented minorities and females. And so they're in my classroom, and I'm telling them things, and they're saying, that's it? That's all I have to do to get this to work, or that's all binary is? They're just not being taught, and they're not being asked to learn about it. And then I'm saying, go, create. And I have baseball players, I have football players, I have lacrosse players, I have like a bunch of athletic students. It's not, I think one student you may in my class you may consider a geek. The rest of them are just your average everyday demographic in the classroom, and they're having a great time.
So we do have professional development offered. You can check out bjc.berkeley.edu for for signing up for us. And we also have an online course that's free that anyone can register for. And if you contact us, we'll actually set it up so you can have your students taking the course within a small private section that you manage yourself, similar to some of the CodeHS stuff that you saw. We are in New York City, and we have a community on piazza.com which you can use to, if you decide to teach BJC, you can join in and ask others questions and be in a larger community. Thank you.
How's everyone doing? Last session of the day, last people to go in the last session of the day. So we have a very special place right now. Okay, so with that, as I start getting the presentation up, we have a thing that we like to do at ScriptEd at our hackathons when it gets to be about 4 o'clock in the afternoon and our kids have been coding all day long and they've got to stand up and move. So I want everybody standing up, everybody up. We're going to do a shakedown. Get you loosened up, ready for our presentation while Becca gets the slides up. So I'm going to count down from 5. We're going to shake each limb. We're going to go 5, 4, 3, 2, 1. 5 on each limb, then 4 on each limb. The end, we're going to strike a pose and make a noise like this. Okay, ready? So here we go. Everybody has to say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 1, 2, 1, 2, 1, 2. 1, 1, 1, 1. We almost got it. All right. All right. Hello, everyone. Let's go to our first slide. Can you go back? Just click like that. All right, hold on. Okay, so I'm Moria. I'm the founder and executive director of ScriptEd.
My name's Shane.
I'm Becca. And I'm Erica. Okay, so what is ScriptEd? ScriptEd's a nonprofit that helps students from low-income communities access careers and technology. For the first 6 years of my career, I started as a TFA core member in Philly and transitioned to a job in New York City. I worked with about 1,000 kids from low-income communities, all of whom were super obsessed with technology, but never really expressing any interest in doing that in their future. And I thought that was really strange because I saw kids on iPhones all the time, playing with Facebook, Twitter. It was really difficult to separate them from their technology, but it was something that they just weren't saying they wanted to do when they grew up. I transitioned jobs, and I had to start learning a little bit about how to code. And as I started learning, I kind of started thinking about this a lot and thinking, you know, why is it that my students don't have this skill, and what can I do to bring them this skill? And frankly, it was a lot because it wasn't offered in schools at that point. Their parents weren't in the industry. Their teachers didn't know a lot about the industry. So how was I going to go about getting this into schools and getting this into the hands of kids? So what I did was I recruited some friends to go to a school and teach it as an after-school club. And within the first week of our first class, we had Time Magazine write up an article on us, which was crazy and awesome. And from then on out, this is in 2012, it just has grown ever since. So basically, we started getting a whole waiting list of people who wanted to go volunteer in classrooms. We had tons of schools reaching out saying, can you bring this to our school? And that is true to this day. So now we are in 30 schools around New York City. We're working with about 600 kids this year. And in addition to teaching our curriculum in web development, which we'll go into in a little bit, we also place kids in internships, and we're up to placing about 150 kids into paid internships over the summer. So Shane is going to talk a little bit more about our program model, but very briefly, what we do is we recruit volunteers from the tech industry to go into schools, particularly into under-resourced high schools, so schools where at least 75% of kids are qualifying for free or reduced price lunch. That means schools where the average income of a family of 4 is around $40,000 in New York City. And we're teaching them a year-long curriculum in web development, both in the school day and after school, depending on what the school prefers. Then over the summer, we place our students into paid internships. We've also rolled out a few other programmatic areas. Our big goal is to get kids into careers in tech. So once a kid starts in script ed, we're kind of committing to helping them all the way through to that tech career. This is our mission. And I'm going to give it to Shane to talk about our program model.
Cool. Great. So the first thing I'll talk about is our foundational course. And our foundational course is where the bulk of our students currently are. And so our foundational course is the one that's taking place in schools, either as an elective during the day or as an after-school club. It's taught by teams of 4 professional software engineers who volunteer their time. Classes happen twice a week, either for 60 minutes or 90 minutes, depending on the school schedule. And they are using a curriculum that's been developed over the years with a lot of volunteer input that walks through HTML, CSS, and JavaScript, all the front-end web development. And after the students have taken their foundational course, as we expand, we're growing into our advanced course. So right now we're partnered with 5 great companies throughout New York City who are hosting students who are either in their 2nd or 3rd year of script ed, and students who are doing more independent projects, continuing their practice in those three programming languages. Again, these classes are taught by 4 volunteers. Oftentimes our advanced courses are being taught by volunteers from the companies where they're being held. And so what's great about that is as Maureen mentioned, our goal here is to get students on the path to careers in tech. So for a 2nd year or 3rd year student who's getting to do programming not in their classroom but in a professional workspace, that's a whole lot of fun. The third part of our program that we're really excited about and also speaks to that goal of putting students on the path to careers in tech is our internship program. And so our internship program is growing, and we're really excited about that. And what we do is we place as many of our most passionate and successful students as possible into paid 5-week internships over the summer with lots of different companies throughout New York, either tech companies or companies that have large tech departments where students get to put the work that they've done throughout the course of a year into action and develop even greater tech skills as well as greater professional skills for being in that environment. A couple other parts of our program. As we're growing, we're beginning to have more and more alumni, which is really exciting. So we're beginning to think about how we're supporting students who have graduated high school and gone on into college, how we're providing them with mentorship and resources on the path to careers in tech. And then finally, I want to talk a bit about our hackathons and field trips as well. So hackathons we do twice a year. So we bring hundreds of our students to a place, we give them a theme, and then we set them up for the day with supportive volunteers to create awesome projects that come into their head based on those themes, and they get the chance to present those projects at the end of the day. It's a whole lot of fun. And then lastly, we've been leveraging our relationships with partners in the New York City area to do as many field trips as possible, so that we're bringing our foundational students into these professional spaces, really getting to imagine themselves as folks in the tech career, which is really exciting.
Yeah. Hi guys, I'm Becca. I'm our program director at Bay Area 10. What's up? I wanted to show you one of our sample hackathon projects to show you kind of the impact of the program. Our kids are really creative, so hopefully I will be able, come up. Oh, I see. Okay, so this is our hackathon project, the winning project from last fall's hackathon. The theme was rainbow, so the kids could create anything over the course of the day that fit with the theme of rainbow. The volume will need to be up on this. This team, the pitch was the students came up and they were like, sometimes you get home from school and you're just so tired and all you want to do is you just want to listen to music and draw. So they came up with all the colors of the rainbow, and I think the other colors, the music links no longer work, but fingers crossed for purple. It takes a second to get started. You can imagine how this might be fun after a long day in class. Yeah. So anyway, I just wanted to show you like how creative when we let students go, the kinds of things they come up with are more than we might think. No close current tab. There we go. Okay, so to talk a little bit about the impact of our program, Moria talked a bit about the scale of how we've grown. When I joined ScriptEd 2.5 years ago, we were in 6 high schools with about 100 students. We placed 20 students in internships. This year we have over 600 students enrolled, and we're going to place over 150 kids in internships, which is really, really exciting. Our impact goes beyond the numbers, however. I wanted to talk to you about 2 students in particular. This is Kobe and Lilibeth, both of whom attended Harlem Village Academy's high school in Harlem, New York. Kobe here, he really, really struggled in school. He really struggled with attendance. He really hadn't found his niche until he joined the coding club, ScriptEd. He bonded really closely with the mentors in the club. He would stay late after program to continue working on advanced programming projects. And he had his first ever paid job as a paid summer intern at American Express working in software development. This is Lilibeth also. Yeah, it's awesome. Lilibeth here, she also joined ScriptEd at her school. She interned with us twice at Contently and Getty Images, I think.
Yep.
And then she's now in college. She's double majoring in women's studies and computer science because she's very passionate about getting more women into the field.
First in her family to go to college.
First in her family to go to college as well. Yeah. And I think these 2 students kind of represent what we're trying to do, which is not only give students, marketable technical skills that the industry is demanding, but also real exposure to the industry so that they can see themselves in the future. So that's the relationships with the mentors in the class, the field trips, and then the internships, which is something that goes on their resume. So we find that's very, very important. So I'm going to pass it off to Erica to talk about how you could get involved in what we're doing.
So I'm sure you're all wondering, how can I replicate this in my school? We're all former core members, and we don't have backgrounds in CS, but we really value the content knowledge that our volunteers bring into the classroom. And so if you're a teacher and you don't have, maybe you don't have the capacity, or you're a school leader and your teachers don't have the capacity to teach this, we bring in the teachers, and you can absolutely do this wherever you are. And partner with companies, bring field trips. Our curriculum is hosted on GitHub, which software developers use to, and it's open source as well. So it's really—
You can find it on our website if you need to
absolutely.
find it.
Yeah, and if you're in New York, we're looking for a few more school partners, so send us an email. If you're not in New York, also send us an email because we might consider coming to you.
And finally, we're hiring. We continue to grow. There's a huge demand for our programs still in New York, and we have open positions. So if you're interested, we're looking at a new market for this fall too. So even if you're not in New York, please be sure to reach out to us.
And this is how you can get in touch. Thank you all so much.
Thank you.
Sound effects. Well, thank you, everybody. Thank you, ScriptEd, for closing the last sub-session of the last session of the day. And I just want to say thanks to Emmanuel from ScriptEd, Jeremy from CodeHS, Tiffany from Beauty and Joy of Computing, the entire team from ScriptEd, as well as Johnny and Jayshree. If any of you want to, well, actually, I would love for you all to look at any of the options we looked at for introducing them in your schools. If you want to know where to find them, all of the groups you saw from are listed at code.org. If you click the Teach button, you can see them. So thank you so much for joining us today, and please add computer science to your schools.